go. All right, so let's get to this 4-7 roots of polynomials. So here's the main idea, and we're gonna kind of get this once we get to the lesson. But the main idea is this: that you should notice that the number of, or I guess you could say the degree of a function matches the number of factors that it has. Okay, that's actually kind of like the main idea they're talking about. Now, I know they say on task 1, it says your teacher is going to provide you with 8 polynomial functions and their graphs. I just figure I'm just going to put them on Desmos. That way you guys don't have to have a bunch of paperwork all around you. And we're going to answer the following questions. It says each of these functions can be expressed as a product of their linear factors as seen in the table below. So if you look at the table, let me just kind of show you guys. Here's the degree of 2. And notice it has 2 factors, right? The next one, degree of 2, 2 factors. Okay, degree of 3, 1, 2, 3 factors. Okay, and if I keep going, right, degree 3, and then 1, 2, 3. If I go to a degree 4, then how many should I have? 4 factors, right? 2, 3, 4. You guys see that? Okay, that's kind of interesting. That should be something maybe you write down on the side and say, like, real quick note, the degree equals number of factors. Okay, so that's kind of something you should see. Like, okay, a degree of 5, look at the very last one, n of x. That's a degree 5. If you look at the factors, there's 1, 2, 3, 4, 5 different factors, right? So here's degree 5, and there's 1, 2, 3, 4, 5 factors. Okay, so kind of an interesting thing to notice, because if someone ever says, hey, here's a function, and they have it in 3 different factors, they're like, what's the degree? You should say, well, 3 factors means it should be an x cubed, right? It's a cubic function. So now there are little things that can switch based on other powers, but right now, based on what we're doing, you kind of see that, okay? But it can change, but at least for now, that's what they want you to do. Now, they do want you guys to notice something about the vocabulary that they're going to use. So as we move up just a little bit here, they say the words x-intercept, root, and 0 are all the same, okay? They're all the same. They all mean solution. That's another word, actually, a 4th word that people will use. They'll tell you, like, find the solution of the graph. That means find the root, or find the 0, or find the x-intercept. It all means the same thing, okay? So just a real quick note right here for you guys to maybe write down. We're just going to say root, or solution, or x-intercept, or 0 means where the graph touches the x-axis. That's what a root is, okay? It's where the graph touches the x-axis. And remember, they might say find the solutions to this graph, or find the zeros, or find the x-intercepts. Find the roots, okay? So that's what it means. That's where the graph is, like, going through it, or maybe bouncing off of it, or whatever. But the point where it touches the x-axis, that is your root, your 0, your solution, your x-intercept, okay? So again, something interesting for us to know about that, some kind of vocabulary for us to know. Now, here's a part where I'm going to kind of jump back and forth through Desmos, but it says, examine the graphs you are given and the expressions above in both standard form and factored form. Okay, so in other words, they're saying if you look at all these equations they just gave us here, they've been factored up there, right? They're saying, so know that. They say highlight the x-intercepts on each graph, then fill the chart below. So we're going to start with f of x. Okay, the degree we know is a degree 2. Let's fill out the degree for all of them. Okay, so the first function is a degree 2. g of x also of degree 2. H of x is degree what? 3, right? J of x is 3. K of x is what? 4. And L of x also 4. M of x, that's a 5. And N of x also 5. So that's pretty easy, right? No big deal. But then they say, find the x-intercepts. Now, in order to do that, I got to graph them. So, let me go over here and show the first graph. How many x-intercepts does that one have? 2. They say they want me to list them, okay? So I'm going to touch them, -2, 0, and 0, 0. So let's go ahead and put that on the assignment there. So -2, 0, and 0, 0. We might have to write really small once we get to the 5s, okay? So the number of solutions, the number of x-intercepts was 2, right? I found 2 points. All right, let's go to the other one, the g of x. So I'll go back to Desmos. Turn this one off, turn this one on. We'll zoom in just a little bit. If you look, it touches the x-axis 2 times again, right? So it's right there at -0.5, 0, and at 0, 0. Now remember, what they wanted you to do is I was supposed to print everybody out one of these sheets with the graphs themselves, and then we were going to just basically look at them like what we're doing right now and then identify it. So I figured I'd save some paper, right? Let's just use our technology here. So let's put that up. -0.5, oops, 0, and 0, 0. And how many roots? 2. All right, let's go for h of x. Okay, h of x. So there it is. How many solutions does this one have? 3. 1, 2, 3. All crossing the x-axis. Okay? So where it crosses the x-axis, those are called roots, solutions, zeros, x-intercepts, right? So -1, 0, 0, 0, and 1, 0. So let me put that right there in our notes. So -1, 0. I'm writing kind of small, okay? 0, 0, and 1, 0. And the number of roots was 3. You noticing anything about the degree and the number of roots? They're the same, right? So, okay. Let's go to j of x. So there's that graph. Okay, we can zoom out just a little bit if you want to kind of see a little bit more of it. So when I click on it, I look to see where it crosses the x-axis. It's going to cross once, twice, and 3 different times, right? So 1, 2, and 3. So I'm going to write down those answers, okay? -1, 0, 0, 0, and 3, 0. Okay, so -1, 0, 0, 0, 3, 0, and the number of roots should be 3. All right, so we're going to k of x. So notice you should pretty much already know what the answer is for number of roots. It's just the actual x-intercepts that's a little different because we don't know those exactly. But let's go to k of x here. Here's a 4th degree. Okay, so if I click on the graph, I see it crosses the x-intercept or the x-axis 4 different times. So 1, 2, 3, 4. So -2, 0, -1, 0, 1, 0, and 2, 0. So let me write that out. So -2, 0, -1, 0, 1, 0, and 2, 0. And that has 4 intercepts. I know I'm getting really small in my writing, but I think we're all going to have to get it to that point unless you want to carry over. All right, so L of x. There's L of x. So if I click on it, here's 1, 2, 3, 4 answers. Notice it's the same exact solutions. Not that they all have the same exact solutions, but in this case it does. -2, 0, -1, 0, 1, 0, and 2, 0. So I'm going to write those down. Again, -2, 0, negative 1, 0, 1, 0, and 2, 0. And the number of roots is 4, right? So I'm expecting to write 5 different answers in this next one, so I'm definitely going to carry over. Okay, I'm just going to save myself a little bit of time and put a 5 there. Okay, because I'm assuming, based on what we've seen, that this should be true, right? So I'm going to go to m of x. And that's what it looks like. I mean, actually, if we zoom out a lot more, that's more like what it looks like. But we're going to zoom into the x-axis here. Has 1, 2, 3, 4, 5 answers. Okay, 5 different solutions. Negative 4, 0, negative 3, 0, 0, 0, 1, 0, 2, 0. So let's write those out. So negative 4, 0, negative 3, 0. What was it? 0, 0. And then 1, 0, and 2, 0. Thank you. And 5 solutions. Okay, so that's fine. 5 different solutions. And the last one, n of x. There you go. So if I click on the graph, it shows me 5 different points where it touches the x-axis. Negative 3, 0, negative 1, 0, 0, 0, 2, 0, and 4, 0. It's 5 different answers like we kind of figured, right, that we were going to have. So let's put that right here. Negative 3, 0, negative 1, 0, 0, 0, 2, 0, and 4, 0. So I'm going to give you a minute, okay, and then we'll write something down. But think about this. They say explain the relationship between the degree, the number of factors, we talked about that in the very beginning, right? The number of factors and the number of roots. Okay, so think about that. I'll give you a minute. I'm going to put for now the degree equals to the number of factors. I forgot to put an F there. Number of factors, which equals to the number of roots. Like I say, for now, that's true. Now, it's actually always true, but the type of roots we get could be different. They could be real or they could be imaginary. And right now, they're just assuming they're real answers. Notice we got 5 different points for powers of 5, 4 different points for powers of 4, right? But there are cases when certain graphs don't touch properly, okay? What do I mean? Well, let's check out this picture really quick. So this is, if you look, it's kind of hard to see, but on the very bottom, p of x, it's a 5th degree function. Okay, 5th degree. How many answers should I have? 5. How many do I see? The bottom one doesn't count because that's not an x-intercept, right? I have 2 answers, but I'm supposed to have 5. Okay, why is that? Well, it's something called multiplicity. One of these answers actually repeats 4 times. Okay, negative 3 actually repeats 4 times. I can tell you that because you see how the graph goes to the x-axis and then all of a sudden it's like the x-axis put a force field on and it like kicked it away. So it went up and then it just pushed it back down. But then when you look at the 0, 1, the graph was going up and then it's kind of like I said, okay, you can pass through. So it kept going, right? When it gets kicked back, that means that that answer happens more than once. Okay? When it goes through, it can happen more than once as well, but it's by odd numbers. We'll talk about that right now with multiplicity. But yeah, like there are 5 solutions here. It's just that negative 3 occurs 4 times, and then 0 occurs once. So that's 5. Okay? But let's get into that right now. But I just want to show that to you guys really quick. So go to page 2. Okay? Let's answer question 3 real quick. Why does each factor match one of the roots? Okay? So, in other words, they're saying if for some reason we had, let's say, x and x minus 2 and x plus 1, and we noticed that the answers were 0, one was at 2, and one was at -1. Okay, one of the points, for example. So if I wanted to, I could say like 0, 0. That would have been one of them. 2, I'd get 2, 0. And at -1, I get -1, 0. They're saying, do you notice how the points always matched one of the factors? In other words, when I use 0, that was used to match up with this one right here, right? And the way I got 2 is using this factor, and the way I got a -1 is by using that factor. What did I do with those factors to get those numbers? So I changed the inside sign. That's one way you could do it. I don't think they mentioned, well, they actually mentioned it right here, but later. See that 0 product property? All you have to do, which besides you could also change it, that's just a shortcut, but all you do is you get each factor and set it equal to 0. And if you were to solve each one of those factors, guess what? You get 0, 2, and -1. So when they're saying why does each factor match to one of the roots, is because when you solve for the factor, it gives you your root. Okay, so I'm going to write that right here. When you solve each factor, you get the roots. I'm going to kind of highlight that. That way at least you know that's the answer. That goes there. Okay, but that's why they always want you guys to like know how to factor stuff. Why is it important? Well, because eventually we start doing harder stuff that requires you to know how to factor so you can find answers. It's not like we just want you to factor for fun. I mean, I don't think I've ever had a lot of fun factoring. Maybe sometimes it was interesting, but never like came out really happy doing it, right? So they're just basically trying to tell you, like, now that you know how to factor for a while, now this is how you're using it. This is how you're going to find things using those factors. Now, they say a disturbing example. Okay, so it's the picture I just showed you guys. Okay, it says, based on your observations above and the degree of the following polynomial, how many roots would you expect? So I'm going to put this should have, I'm going to put should have, how many roots? 5 roots. Okay, they say explain. So I'm going to say the degree, I'm just going to put degree equals number of roots. Right? So, I mean, I'm not wrong in saying that sentence right there. It's fine. They say now factor that function and use the 0 product property to solve the roots of the polynomial function by this expression. Start with the GCF. How many roots does this polynomial have? So, here we go. So, let me factor this thing here, okay? This expression. I'm going to factor it out. So I'm going to take out an x cubed first. Okay, if I take out x cubed from all of those terms, I end up with x squared plus 6x plus 9. Okay, now just for the purposes of time, let me just double check here. Are we done in... Oh, no, wait. Sorry, I thought it was 30. We got 8 minutes. For the purposes of time, I'm just going to factor the next one. I'm going to do it in my head. Okay, using the x method, I get this. So there it is. There's my factored form. Okay? Because it's x plus 3 times x plus 3, which is just x plus 3 squared. How many roots does this polynomial have? Well, it has 2 roots. Because how many factors does it have? It has 2 factors, right? It has x being cubed and x plus 3 being squared, right? So it has 2 roots. So let me write this right here. This has 2 roots. Now let me actually solve for them. Okay, I'm going to do this right here on the side. If I get x cubed equal to 0, would you agree with me that the answer would have to be x equals 0? You guys agree with that? Right? It's just you plug in a 0, you get 0, right? All right, so one of the answers is 0. For the next answer, if I get x plus 3 squared and set it equal to 0, I'm supposed to square root both sides. And I get x plus 3. Let me get rid of the parentheses. X plus 3 equals 0. So that means x has to be negative 3. Are you guys okay with that? Okay, 2 solutions, right? 0 and negative 3. Okay, so I'm going to put 0 and negative 3 are the roots. But I only got 2 roots. And I'm supposed to have 5. How the heck does that add up to 5? Okay, where did I get the 0 from? Well,
3.
The x cubed part, right? The power tells you how many times that solution occurs. So the 0 happened 3 times. Okay, how many times did the negative 3 occur? We got that from here. Maybe if I get rid of the square root.
The 2.
The 2. That means the negative 3. So we had 3 for the 0, and we got 2 for the negative 3. Together, it adds up to 5. 5 solutions. We call that multiplicity. Okay? Whenever an answer comes out more than once, we say it has multiplicity of 2 or 3 or 4 or 5, whatever the power happens to be. So I could say 0 has multiplicity of 3. That means it happens 3 times. Negative 3 has multiplicity of 2. Let me kind of put this in highlighted form so you guys know. Okay, now I know I'm kind of skipping ahead because that happens, I think, in number 6, but just wanted to teach that to you guys right now. So let's look at number 6. What does it mean for a polynomial to have a root of multiplicity 2 or 3? So I kind of said it out loud. If it has multiplicity 2, the answer comes out how many times? Twice. If it has multiplicity 3, it comes out 3 times. So go ahead and write that down. Okay? So to have multiplicity of 2 means it occurs twice. To have multiplicity of 3 means it occurs 3 times. Let's see. Let me just write it down right here. The root occurs 2 times. Okay, and to have multiplicity of 3 means the root occurs 3 times. So if I say multiplicity 7, then you know it happens 7 different times, right? So, all right, the last thing right here. Number 7 says, revise your statement from the bottom of page 1 to include the possibility of a root of a multiplicity greater than 1. Okay? All they want you to do is put some roots could be repetitive. So instead of finding 5 distinct answers, you might find 2 answers, but that eventually repeat a total of 5 times. You get that? So it's not always going to be the exact number of solutions every time. You might just find, for a power of 4, you might find 1 answer and 1 answer, but yet they both repeat twice. So that's 2 and 2, that makes 4. Okay? So that's what I'm saying. Some roots could be repetitive. Now, they want you to try this on your own. Tomorrow we'll discuss, okay? And then tomorrow we'll continue with the rest. But try just this little box on your own.